Today, we'll be looking at logical data replication and what it allows you to do with your CockroachDB clusters. Let's say you're running a US-based business with customers primarily on the East Coast. And by year 2, your business is starting to expand throughout the States, and now you have customers on the West Coast. For a time, you might be able to serve those West Coast customers from your East Coast cluster, but eventually the latency across country won't be giving customers on the West Coast the best experience of your application. At this point, you might want to introduce a second data center on the West Coast that serves the West Coast customers. Today, I'll show you how to do that with logical data replication. What we'll be creating today is a simulation of that very setup. We'll start with a cluster on the East Coast, and perhaps we don't have access to 3 data centers, so we only have the option of working with 2 data centers, and therefore logical data replication makes a lot of sense for this use case. Customers interacting with the East Coast will get strong consistency for their reads and writes. And once we bring on the West Coast, customers talking to the West Coast cluster will get strong consistency to that one. However, consistency between those clusters will be eventually consistent. So what logical data replication allows us is strong consistency at the data center level and eventual consistency between the data centers. When we start up our West Coast cluster, I'll start streaming data from the East Coast cluster asynchronously via a unidirectional logical data replication stream. And eventually, we'll want both sets of data to exist in both clusters. So eventually, we'll have a bi-directional replication stream. For this demo, you'll see me using Cockroach Beta. That's just my local version of the 24.3 test binary. By the time this video is released, all of this functionality will be available in the Cockroach binary. And I'll create my database and tables. They look like this. I'll create a store database. This will be an e-commerce workload with a member table, a product table, and a purchase table. Range feeds are required for logical data replication, so I'll enable that on both of the clusters. And I'll simulate my East Coast customers. We're now 1 year into our fictional business, and we've decided that we can no longer allow the West Coast customers to suffer high latencies when talking to our East Coast cluster. Let's set up the West Coast cluster to better serve those customers. I'll create the exact same schema objects, and then I'll connect to the first node, the East Coast, and I'll create a user. The West Coast cluster will connect as this user to perform replication from the East Coast. Note that because I'm using an insecure cluster, I don't provide a password, but for the love of all that's holy, you should be running a secure cluster with passwords. I'll grant replication to that user, and now we're ready to start configuring the West Coast for replication. I'll create an external connection called East Coast Store, and that will point the West Coast cluster to the East Coast cluster. And it means that database operators can harness external connections as opposed to having to know sensitive credentials. I'm using the Store Replicator East user that we created before, targeting the East Coast cluster, the store database. I'm pointing to the system tenant, and I'm running insecurely. The only thing left to do now is to run the replication stream. And that looks like this. Create logical replication stream from the tables that we want to replicate. In this case, I want to replicate all the tables in the store database. That's currently member, product, and purchase. And I'll be replicating them from our external connection that points to the East Coast cluster. And I'll be replicating into my member, product, and purchase tables on my West Coast cluster. There are 2 replication modes available. The default is immediate, and that makes direct inserts into the KV layer. But because I'm using foreign key constraints, I need to use validated. And that'll be the case for you if you have any foreign key constraints between your tables. With that set up, we'll now be replicating East Coast data to the West Coast. And the replication stream is simply a job on the CockroachDB job infrastructure, meaning that it's already highly resilient and it runs with the help of admission control, meaning that your foreground workloads will be protected in the event that your cluster starts to encounter CPU or memory pressures. CockroachDB will prioritize your foreground workloads, i.e. the workloads that are servicing your customers, over logical data replication. And there's our job. It's running and it shows the tables that are being replicated. Now let's start simulating West Coast customers. And as you might have guessed, because we're streaming data from the East Coast to the West Coast, and we're now simulating West Coast customers, the West Coast cluster will have more data than the East Coast. And that can be seen from a select. We're essentially not replicating bi-directionally. Let's do that now. On the West Coast cluster, I'll create a user and grant it replication permissions. This is what the East Coast cluster will use to replicate data back from the West Coast. Note that CockroachDB will figure out what data needs to be replicated, so there's no duplication of data. I'll create an external connection to the West Coast and start my replication stream, this time replicating from the West Coast to the East Coast. The job can be seen just as before, and now the row counts will be much closer together. That was a fluke. What I'll do now is simulate an outage in the West Coast to see how customers in both localities are affected. I'll get the process ID of the West Coast cluster and kill it. You can see that customers on the West Coast are no longer able to talk to the database, while customers on the East Coast are running unaffected. I'll resume the West Coast. And now the West Coast is back up and running, and the replication stream running on the jobs infrastructure will carry on as normal. But I do need to reset my connection. So everything continues just as it did before. I'll now stop the customer simulations and allow replication to settle, just to show you that both of the clusters have identical data now. If we have a look at the counts, they're identical. All the East Coast data exists on the West Coast and vice versa. If you didn't already know, there are 2 additional metrics dashboards available in the Cockroach UI, and these show data for physical cluster replication and logical data replication, which is what we're doing. Let's click on that. And what this shows is any latency that's being encountered between the replication streams, the replication lag, the number of rows updated, the number of bytes received, the amount of time it takes to write batches of rows to the replication target, information on why something might have ended up in a dead letter queue for later manual processing, and the size of the retry queue. That was logical data replication for the 2 data center workload. However, there are a bunch of other use cases that you might want to consider that are now unlocked because of logical data replication. Perhaps you want to have a hot cluster for transactional workloads and then logically replicate data over to an analytical cluster that performs heavier queries that you don't want to run on your transactional cluster. You can essentially protect your production workload. You might also want to have a production cluster and replicate data to a staging cluster for testing purposes. If you have customers spread across geographies but don't have access to 3 data centers to enable CockroachDB's default multi-active replication, 2 data centers with logical data replication could be a great option for you. As I've just shown, and as with many other CockroachDB features, logical data replication was built to be robust. It will react to and recover from a bunch of outage scenarios that you wouldn't necessarily be able to recover from with a traditional monolithic database. And it was built for some of the world's most demanding production workloads. Give logical data replication a try today and see how it could benefit your workloads.